Okay, so going for another physics doubt, we have a mechanics question here, and this is projectile motion. Now what we have here, a circus performer is shot out of a cannon at an angle of 40 degrees with the horizontal, with a speed of 30 meters per second. He lands in a net at the same height as the end of the cannon, a distance x from it. And the question asks us, what's x? Neglect air resistance, and and assume that those are at the same height. So up to one significant figure. So what we have to observe here is when we have a projectile motion, we will have two independent motions. So we have a motion, there is a motion which is upwards. So if we look, for example, from the back of the cannon here, or if there's someone here who's actually lighting up the cannon, that person would only see this performer going up and down and falling in the net. If we're looking from here, we will see the projectile motion perfectly. If someone was looking from below here, if the person was lying down and looking up, that person would just see this going forward, right? It would see just a movement forward up to when it falls. So we can split this motion into two different motions, one only on the y-axis and only one on the x-axis. So when is this going to this length here will happen when this goes basically all the way up and down. So when it reaches the same level, then it's when it fell. And what we would do here is try and find how long would it take for it to fall, and then you see how far this would go on that time. So first thing that we have to do is split this force. So we have to decompose that force into its components. So we will have a vertical component and a horizontal component. You've got the formula for those, but since this is 40 degrees here with the horizontal, I know that this horizontal component will be 30 meters per second times cosine of 40 degrees. And here, 30 times sine of 40 degrees. Now, for now, I am not going to work out those values. I'll just leave them as they are. 30 sine of 40, 30 cosine of 40. Why? Because if I calculate those, I will have some rounding. I will have to do some rounding to write those numbers down. So for now, I'll just leave them as they are, and we're going to do all calculations and we're going to put the values at the end. So it's going up initially by a speed, so I'll call this uy, which is 30 sine of 40. Now, just for you to have an idea of the values, that initial velocity on the y-axis would be about 19.3 meters per second. If we were to round those already, we would have a very wrong number, right? A huge discrepancy. So again, for now, we're going to keep the signs, but just for you to have an understanding of how large that value would be, that would be around 19.3. So this motion up and down is what we call free fall. And in a movement such as free fall, we have some things which, some important information. The first one is that our acceleration is constant, but not only it is constant, we know the value. We assume it to be around 9.8 when it's not given, or around 10. The huge problem about using 10 is rounding errors. So I will just tell you to use 9.8 when nothing is said, and you round at the end. This question is not asking for a lot of precision, it's only one significant figure. But we have to carry forward everything, and then at the end we can round. Otherwise we might round to wrong things in the beginning, and those errors, they might grow larger, and you might get something which is really off, and it might not even be considered for any marks. So in this case, since our acceleration is constant, any velocity that we calculate afterwards will be our initial velocity plus our acceleration multiplied by how long it took. Now, there are two ways for you to solve this. The first one, which is usually just to assume, okay, how long do I take to get to the top? And that would be exactly the same time to get down. So you could just assume that your final velocity is 0, and you could calculate how much time did it take to go up. Another possibility is for you to interpret, okay, it went up and then down, and when it's going through this point here, it will have exactly the same velocity, but on the opposite direction. So the same magnitude, the same speed, but opposite direction of the velocity vector that we had in the beginning. So we could, for instance, do negative 30 sine of 40, because I'm assuming that positive is up. Let's just do that. Okay, so if I assume that positive is up, my final velocity, which would be down, would be negative. My initial velocity is positive because it's up. My acceleration is negative because it's pointing down, and I don't know the time. So here you can see that we can just rearrange those to get the value of the time. How much did it take for that performer to fall down? So we would have time equals, if we get this to the other side, we'll have 2 times that. So that would be 60 sine of 40 divided by 9.8. Notice that all signs would be negative, and then you can just get rid of the signs. If you want to keep them here, that's fine, because then negative with negative, you will have something positive. So this value turns out to be 3.9, and I'll keep the 3, that's fine. That's a bit too precise for us, right? So yeah, I'll instead just write 3.9. Okay, if this was our result, if this was the answer, if we would have to round it to one significant figure, it would be 4. Okay, but since we're not looking for the time, we'll keep 2 significant figures. Now that I know how long it took for it to fall up and down, all we have to do is verify, okay, how long then would it travel after exactly 3.9 seconds? How far would it be horizontally from the beginning? So our horizontal velocity is this one, and since there is no acceleration on the horizontal frame here, on the horizontal direction, this velocity will not change. Therefore, if we want to calculate how far we have walked, we could do a ratio, how far we go per time. That would be our speed, in this case our horizontal speed. So if we rearrange this, we'll then get, oops, calculators, there you go. So distance over time will be speed, in this case speed, horizontal speed. So if we rearrange this, we will have then that the distance traveled will be our horizontal speed multiplied by the time. And if you didn't put the numbers in, you would have a very beautiful and nice equation. It would turn out to be ux in time before you calculated the value. Take a look, what was time? Time was the sum of both velocities on y, which are the same, but I'll put them differently just because, over, and this is negative, and here gravity. This is exactly what we did to calculate our time. If you know that those two are the same, you would just have 2 times your horizontal speed, vertical speed, and you would divide by gravity. But here you would just put numbers in. You wouldn't put any any signs. So gravity here will be positive. Velocities here, they would be just the absolute value of those. So you could even, if you want, if you remember that those are vectors, right? You can just add the absolute value. Because here we are assuming that they are the same, but they are only the same on the absolute value, not the sign. They are actually opposite directions. But when you divide by gravity, you get rid of the negative sign. So if you calculate those values, you would then find that your displacement, or the distance that this person has traveled, was around 90.4 meters. You can even see that the units, they work out here, right? Because you've got speed, meters per second, speed, meters per second, gravity, so acceleration, meters per second squared. So if we get rid of our seconds and one of those meters, our result will be in meters. Since we're being asked for one significant figure, this will be 90 meters. And that's done.